and this, and this. Okay. And theoretically, good. And now some kind of garbage on my screen. Okay. And this thing. Okay. All right. So that will permanently vanish at some point. So here we are in 128, and we're down to here. So we're doing the second part of chapter 7. Third part is next time.
There's no 7b. It's chapter 7. You put 7b.
There is no B. I don't know what you're talking about.
You haven't updated your slides yet.
Yes, I have.
Well, I went on the quiz thing tonight for quizzes, and there's no quiz 7b. It's a 7.
It's 7 part 2 or something.
No, 7. No,
it's there. It's there.
Oh, okay. When I was doing it, I was going.
It was up there a week in advance, like they should be. The only thing there isn't is 7C yet, which I normally would have up by now.
Okay.
But I don't have the 7.
I saw 7. Maybe you put it later.
Yeah, but anyway, I don't have the 7C up yet. But I should have it up by tomorrow, and if I don't, then I'll extend the deadline. Because I've been delayed, which is what I'm going to tell you about. In fact, I can just go right to it, because we had so much trouble at the power that I didn't start early enough to talk about the news, and the news is not that important anyway.
Good news, yeah.
Well, if it's good news, it's totally not worth talking about. So let's talk about, however, this Android stuff is very interesting. So let's start. In the first thing, student asked an important question. If you launch your Genymotion and you can't open your machine, this is almost always the same thing because it's looking for VMware, which isn't there. So first you have to start VMware. You don't really have to run a machine, but you have to have VMware itself running. So it creates the interface. Then you can open your Genymotion interfaces or whatever tablet you're using. Now I've used quite a few different tablets to get through these projects. This is the latest one, tablet 9, which I think I'll be able to use for most of the demos tonight, but I've got quite a few different ones for different cases. And let me get these machines running. The way you set them up, you get a lot of practice at this, as you've probably begun to notice. In fact, I even am going to need Windows later. And also Kali. What's that?
When I was starting my machine, when I had VMware open, I was just doing it when I opened VirtualBox, and it just kind of reset. I don't know. Just
yes.
Weird. So,
yes.
Because I had VMware open.
No, that's absolutely right. It's very unreliable. I was using mine for a while, and it suddenly refused to make the adapter, and I just had to restart the whole machine. All these desktop virtualization products are very buggy, and all the hacking tools are very buggy. So one thing you really get good at is like troubleshooting in this class. You have to bring it up, try pinging end to end. The thing you did just won't work, and you just have to restart it all and try again. It never gets any better than that. It all gets I think up to working like 75% of the time is the best any of this stuff will ever do. And on top of that, even if you get through all that, they keep changing the stuff underneath, like the Android versions and the APK versions. So for example, APK tool keeps failing. I have to keep learning more and more tricks because people keep increasing the complexity of their apps, and the hacking tools don't keep up. So anyway, once I got this thing going, this is supposedly listening. Let's see, IP address. So you have to sort of get a troubleshooting algorithm going. So I start by checking my IP address to see if I have one, and then I like to make sure I'm actually listening. Pant, SS minus pant is socket state minus pant. It used to be netstat, but netstat is deprecated. And so this tells me I'm in fact listening on port 22, so I can connect with SSH, which is what I highly recommend doing. Using this terminal like this is for amateurs. Because you usually can't copy and paste, and if you can today, you won't be able to tomorrow because VMware Tools fails more than half the time. And so the thing to do is just get over it and quit trying to use the terminal, which you're not even supposed to be able to see anyway, and use SSH. So here, I SSH in to that thing, and let's see if it's going to work. It's going to work. Good. I can put in my high security password, and now I've got. What's that?
Your password. He's guessing your password.
Oh yeah, he might be able to guess my password. But that would not be very difficult. That's why. Yeah. You know. I put a password on my website for the news links that was just one letter, and that stopped people for like 8 years. Anyway, it's a matter of threat modeling. I just got yelled at by somebody because I wanted to publish a vulnerability, and I didn't want to just make it open to the whole world. So I put it behind the username and password, and I sent them the username and password in email. They said, you shouldn't have sent the password in email. I said, well, given my threat modeling, I thought that was a good decision. But anyway, so So now I'm in the Kali machine. So the next thing is I have to connect to the Android machine, and the technique I show in the early project is old and painful, and a much better technique is to use netdiscover. That's what I learned now. So if I use Control-R, I can go hunt through my old commands, and there's the handy one, netdiscover, to search my whole subnet. This is what hackers do. It'll ask me for a password, although it doesn't really need one. And what this does is it scans your local subnet with ARP packets, which is extremely fast. It only needs to send 1 packet per IP address. So at 256 is just a matter of a second or two, and it finds everybody on your network. And 4 of these are VMware, and 1 of them is not, and that's the Android device. And depending on which emulator you're using, it has different names, but it's always the one that's different, so it's very easy. And now that you find that, you do ADB connect. It's not listening to me. It's really not listening to me.
New instructions.
It's in one of the projects, but now I don't know why this thing is not answering. Something is dead.
Firewall.
Well, all right, let's see if this is dead. That's not dead. Okay. I seem to have somehow lost my SSH session, which appears to be connected right there, but it no longer responds. Nope, that's totally dead as a doornail. So,
Sounds like something that would happen to be.
okay, well, like I said, this is what I was telling you. All these tools are very, very buggy. So let me try again. It's this stupid address here, IP address. You have to have a lot of patience with everything crashing all the time. So it's, oh, it changed to 178, I think. I think it used to be 155. That's what happened. Right in the middle of my using it, it suddenly changed. How rude. Well, all right. That makes me think that something must have dropped. Probably VMware lost the connection, and it had to do a re-DHCP because all the network interfaces kind of flap up and down like a broken cable, and that's as good as VMware interfaces ever get. Yeah, now it's never heard of this before because it's had a new address. So let's connect and then put in my high security password. And so I'm in again. Let's see if it works now. So it was netdiscover. I can do Control-R. It will look through my history and find that command. And okay. So it's doing the netdiscover, and good, it's finding stuff. So I copy the address, and then I try to do ADB connect, that, and it connects. And I saw a chat message go by. Was wondering if someone would proxy the entire OS traffic for Android via burp. Yes, we do that quite a bit in the project. I noticed some apps traffic, yes, some apps traffic cannot be captured in BERT. This is absolutely true. When I started doing app testing, I would go to the system proxy and set it. And when you do, most traffic goes through the proxy, but some just goes right past it. And you can open up Wireshark and see it going. So what happens is that setting that adjusts the proxy does not really change the fundamental route. It changes certain API calls, which are the more common ones. And you can choose other API calls in your app that will go straight out. Like before Windows XP, Windows would let you have raw sockets if you wanted to. You could ignore the operating system and send packets one by one out the adapter. And if you did, of course, you'd bypass all the defenses, which is why Microsoft took it away. But Linux has always had it. I'm sure Android does too. So there are ways to get to the adapter without passing through the official channels. And so that's why when you go into the Android settings and change the proxy, that is kind of a simple, easy test, but it's not very thorough. What's better is to do the thing I did a couple weeks ago in class where you make a real physical man-in-the-middle attack. You make a Wi-Fi network with another physical device. So all the traffic has to go through. That's the way you really do it. Or and some students talk about setting up a Raspberry Pi to do that. A physical man-in-the-middle is the only way to be sure you're catching all the traffic. Any kind of software patch is only going to get the traffic that uses the software libraries that you expected. So that's an important issue. Anyway, right, so now I'm connected. So now that I'm connected, I could do this. I could do ADB shell and get a shell on the Android device and execute commands. But what I want to do for where we are now is I want to use Drozer. And I can't run Drozer yet. There's a command to start Drozer. There's Drozer console, connect. When I do it, it doesn't work. So here's what's wrong. Obviously, the first thing is you have to run the agent. Drozer works by remote controlling the agent, like remote desktop. You have an agent on the device and you're remote controlling it like TeamViewer or one of those things. And so it has to be listening. So you have to start the Drozer app inside your Android device. So I got to log in with my high security password and start the Drozer app, which is here. and run it here. Now it's listening on 31415, but I still can't connect because that is on 127.0.0.1 inside Android, and I can't get there from outside. So I have to do, this is my memory 280B forward. I have to do this command, forward TCP 31415 to TCP 31415. Now the Kali is forwarding its local port to the Android port, and now I can make Browser Console connect and get the beautiful picture. Let's see what the chat message is saying. Okay, oh, thanks, good, okay, good. All right, so anyway, now I can go in here with Drozer and do things, and we'll be doing quite a lot of these things because the whole class tonight is more deeply into Android than I've ever gone before. And I must say, I had to struggle greatly. Almost everything they say was hard to understand, and almost none of the commands worked. Mostly because the commands are just much more complicated than I thought. It's very easy to miss a part. And in the textbook I have, it's very hard to see the carriage returns and the spaces. So it took me many tries to get it working. And so if you want to duplicate this, I would look at my slides, because my slides have hopefully more clear presentations of the commands the way they need to be. So we talked about this stuff. Now, this is all the attacking application components. And the rest of this stuff is for next week. So here, let me just see if I can encourage this to go away. All right, so trust boundaries are the big issue. And the one thing that is helping me in my going through this difficult chapter to get deeper into Android is the web app hacking book. Android apps are very much like web apps. It's very, very similar. And it's by analogy that I'm able to remember this stuff. And it's the same thing on the web. You have trust boundaries. You have one device, you've logged in, you're only supposed to do certain things, and then every time you do something, it checks. And when you hand your session over to another device, it often no longer understands what you're allowed to do and what you aren't allowed to do anymore. That session management is very painful. And we're going to see that. It's very easy to let someone do something they shouldn't do. Essentially, this is how all privilege escalation flaws work, and every OS has an endless chain of them. Every few months, they have another privilege escalation for Linux and Windows. They never can get rid of them. People get tired of even being mad about it, like cross-site scripting. But the fact is, this keeping you from doing what you're not supposed to do is nearly impossible. No OS can really do it very well. It's so easy to make a mistake, where there is some way to trick it into doing the thing you're not supposed to do. So now Android is, as I mentioned before, the first iPhone just ran everything as root. And everything came straight from Apple. There was no app store. Nothing came from the user, and they thought that was okay, like Kali, run everything as root. But once you start putting on all sorts of software written by everybody, then that's not good enough. So you have to have some kind of sandbox. And the Android sandbox is every app runs with a different identity, but you can't totally isolate them from each other. Because, for example, if the battery's going low, you want it to interrupt whatever you're doing and pop up a box telling you the battery's going low, or if a phone call comes in or something. So the apps have to somehow communicate with each other. And so you have these intents to do that. And the intents don't have any kind of default boundary. It is up to every app to specify the permissions that limit what intents they will take. Therefore, every app designer has to thoroughly understand this. And as you have probably begun to notice, it is pretty baffling and mind-boggling. I don't really blame the developers for not getting it right. I have trouble slogging through this stuff. And if the developer fails to understand anything here and just leaves it at the default, it's probably a vulnerability, and that's why we all get the big bucks and the employment for all of us, fixing all the problems they create. So, all right, so if you have a login screen somewhere and people have to log in before they do things, then you have to somehow remember whether they've logged in or not and make sure to check that they've really logged in before letting them do everything else. And same thing is absolutely true in web apps. So here's a failed trust boundary. And I don't know if anyone else is as dumb as me. It might comfort you to know I spent about 4 hours on the wrong track here. When I saw this picture in the book, I thought they created this picture with Drozer, and I spent 4 hours figuring out how to create this picture with Drozer. And then I finally came back like the next morning after going to sleep, and I realized you just open it. This demonstration is not supposed to be mind-boggling, because what they're talking about here is not Drozer. You go to there and you just open the app. So this is what happens to me in CTFs too. I'll be beating my head against some complicated problem when there was some easy thing. It never occurred to me to try the easy thing. Anyway, so here's all they're talking about. This is just the concept of a trust boundary. If you open SID, remember SID is this password manager, then right here where you enter the password, there's these 3 dots up here, which shouldn't be there. You can click those 3 dots and you can open the settings module before you log in. That's all they're talking about. And this exposes things like backup to SD card, where you can make a copy of the database. There's things here that cause you to get the passwords before you log in. That's all they're talking about. And this is a lot of vulnerabilities like this exist on the web too. So anyway, that's a failed trust boundary. You can do something that you really should log in for first. And that's, of course, the main kind of vulnerability we're looking for. Some way you can go around and get to where you're not supposed to be authorized to be. So if you look at the activities, we've done this before, you can run activity info. And if you run activity info this way, let me bring up my list of commands. I can just copy and paste them, especially for the later commands. This will really help. Okay. So here's a good set of commands. So I'm just gonna, there, activity start, that's pretty good. There we are, activity info. Okay, so here's the one, inside Drozer. Now, here's a fun fact. If you're inside Drozer, you are not root. You are running with the Drozer identity. And so let me point that out for starters. If you exit Drozer here and go in here with ADB shell, you are now, oops, ADB shell. Okay, now I'm root. I see a pound there. That pound is telling me I'm root. And if I go to, say, data, and you're lying. Oh, it kicked me off. No device is found. Oh, I lost my connection again. All right. ADB connect. Okay, now I'm connected again. My networking is really bad. Maybe it's the City College wireless network. Who knows? Anyway, so now I go to ADB shell. Now I'm back on the Android device. Now I can do, I wonder if I can do who am I? I can. Good. So I'm root. Now, if I can switch to other people. If I do go to say data, this is the home directory for everybody, data. So if I do ls, here's all the apps. And if I do ls space -l, then I get all the apps with all their permissions. And so if I wanted to know about Drozer, Drozer is MZ, I think. Let's grep. I think MZ is the name of the company. No, it must be DZ or something. It's MWR. Okay, let's try MW. All right, so here is the sieve, which is the vulnerable password manager, and that is the agent, com.mwr.gz. That's the Drozer agent that I'm using to connect. And so the agent went on first. It was the 5th thing I put on this phone. The sieve was the 30th thing I put on the phone, so that's the user account. So right now I'm root, and I can pretty much do anything, but if I come in through Drozer, I am U0A5, not root. And by the way, I can become that way now with two. If you switch user, I can become U0A5. And now who am I? Is here, and many commands won't work anymore, and I can only access certain areas and all that jazz. So there's, like in all Linux, permissions of whether you're root or not. When you come in through Drozer, you are not root. You're this U0A5. So that's what you do low privilege things. If you want to do something as root, you can do it here in the shell. There may be a way to do it through Drozer, but that's what I'm. So I'm going to exit and get back to root, and exit and get back to my Kali, and then run Drozer console, start again, and it's probably going to fail because when I lost my connection, it lost the port forwarding, of course. Now, so let me put in the forwarding. That's why I'm really glad I finally learned this Control-R, ADB forward. Control-R searches the history, and I never bothered to learn it, but this has motivated me to finally learn it because I have to do the same thing over and over and over. So now I'm supposedly forwarding. I still might not be able to run Drozer though, because nope, see, I think what happened is the app crashed, which is also very common. So the Android crashes, the network crashes, the VMware crashes, and you get a lot of practice starting over and over. And the only thing I'd say is you might as well just get used to it. Anyway, so if it's a little bit better if you run older versions of Android in your emulator, but it's not a lot better. Anyway, so now this is listening. Now perhaps I've got enough of this junk restarted to connect. I get the glorious picture. Okay, so now we can play games with Drozer. And what I wanted to do was look at the app activity info for SIB. So this is something we did in a previous class too, but it's worth doing again to put us back on track. I'm missing the last letter in SIB. Okay, so if I run this command, app activity info -a and then the name of the app, it tells me the exported activities. And so there are 3 exported activities: PW list, main login, and file select. These are exported, which means any user account can send signals to them. So these are expected to be open for anyone to launch. And that's fine. And so, for example, if I run the main login activity, it'll show me the main login page. But the thing I want to show you now is how to see the unexported ones. And for those, you just add a -U here. And when I do this, I get a much longer list. So these are the exported activities, which are the ones that are intended to be available to everyone. And these are the hidden activities, which should only be available to this app. So here you've got pin activity. Set your pin or something, the settings activity, which is that button in the corner that we clicked that took us to a place we shouldn't have been able to get to until we log in, and these sort of things. So those are the more secure app things that are more interesting to attack. And if I try to make these run from Drozer, I will find out that I can't. So here is how you launch a thing from Drozer. So let me first start by running the, I'm just going to do this. I'm going to run something that will work, like the main login activity. So if I copy this main login activity and put it at the end of this long command, there. I think I've got it right. I think that will do it. Let's see if it works. This is supposed to app activity start. The component is the name of the app, and the name of the particular component is the name of the app dot main login activity. This should launch the main login activity. It really is the same thing as clicking the icon on the desktop of the phone. So let's get this back to home and then run that, and nothing happens. Nope, it does happen. Good. So this opens the main activity, which asks you your password. So that is normal and reasonable. And of course, the vulnerability would come if I was able to open things I shouldn't be able to open here. So let's try opening something more fun, like the settings activity. And that's, this is the pin activity. The pin activity is, I think, what resets your pin. So if you try to run that from Drozer, you will get an error message saying unable, oops, I must have a mistake in my, unable to find explicit activity class. Right, because I have the word fails in it. I copied too much of my instructions here. So it was pin activity there. Up here you can see it, com, MWR example, pin activity. You have to have it just that way here. I had some extra letters after it and that'll break it. That's why it took me a lot of practice. Every little mistake, of course, ruins it. So now it understood me and refused. Permission denied. You are not allowed to do this because you are user ID 10005. And the only person allowed to do that is 10030, and it's not exported. So this is the sandbox working correctly, protecting my protected method from being accessed outside the right permissions. So that's good. But I can defeat those permissions by becoming root. And the way I know to become root, although there may well very well be other ways, is to just do ADB shell. And now I'm root. But I no longer have Drozer, so I have to use the native Android commands now. But there's an Android command to send intents called AM, Activity Manager. And so I can do that activity here with AM start. And this one will start settings, which is the same thing, same issue. Settings is also one that's not exported and I can't open it. The only thing that's kind of weird about this one is you have to use -N here, although the documentation made me think it was another letter to help me up for a while. And you have to have a slash here and then a dot there. Even though it shows it without the slash, it doesn't understand it otherwise. The slash separates the name of the app from the name of the particular control in the app. And that was sort of confusing. I spent a lot of time Googling for examples because the syntax is picky and weird. And if you read the help page, it doesn't seem to really make it clear enough to me what to do. So now that launches that setting page. So this, when I first saw this, I thought this is a vulnerability, but it's not really because I'm root. If I'm root, I can certainly activate any part of the app, and that's pretty much by design. So I'm not sure this is necessarily a vulnerability. I'm still thinking about the right way to evaluate it, because I found commercial apps. I immediately saw these commercial apps, and I found all these things that I can only launch as root. And I said, there, I'm hacking in. And I said, well, I'm not really hacking in. And Microsoft often has this argument with people. Like they say, you found a vulnerability in Windows, and they say, but you had to be the local administrator to do that. And if you're a local administrator, then you've already won. I mean, what do you expect us to do if you're a local administrator? How are we supposed to stop you from doing anything? And they've kind of got a point. So anyway, all right, so that's one thing to get straight is how the permissions work and how you escalate to root. All right. So you can't run it through Drozer, but you can run as root from Chell, and that is just by design. That is not necessarily something wrong, I think. But it is a thing to know because it is a reason. Now you're back to your threat model. If your threat model is someone is going to trick me into installing malware, which I highly recommend including that in your threat model because the App Store is full of malware, the Google Play, so you are probably installing malware whether you like it or not. And even if you run antivirus, it's not very effective, just like it's not very effective on Windows. So it is extremely plausible that someone tricks you into installing malware. But malware typically can't become root. So you might reasonably say, I'm not worried about this kind of attack because even if I have malware on my phone, it can only do this, it can't do that. But if you think they're going to root your phone, which would be a case if they physically steal your phone, then they can root it and get everything on it. Then you're in this world, and now you have to consider what your risk is. And that is why I've been trying to get all the retailers to care about storing passwords on the phone. Because the password, they'll say the passwords are in that app's directory and the other apps can't see it, so it doesn't matter. And I've read official, or not official documentation from Google, but recommendations from developers from a few years ago saying that. Just don't worry about it, it's got its own sandbox. But anybody that studies it for a while realizes that sandbox has holes. And if I steal your phone, I can root it and get here. And then I can steal it out of areas. So it's really not a good idea to store it even in the area on the phone. But that is a lower risk. I can easily get 1 million people to install malware. I have to steal phones one by one. So it's a much lower risk. Anyway, all right, so we've seen this. So now let's talk about content providers. Now those were activities which pop up a screen you can see. Remember, there are 4 components of Android devices. There's content providers, activities, services, and broadcast receivers. And so content providers are the databases that store data, and they have all kinds of special vulnerabilities. It just turned out to be, remember, Windows in its early versions like Windows NT was fabulously vulnerable. And Android was fabulously vulnerable at the start because their decision to export all the content providers is like Amazon's decision to make buckets world readable by default. Or for that matter, Mongo's decision to make everything world readable by default. Everyone that does this becomes the laughingstock of the world a few years later when the obvious consequences happen. And Android was no exception. All the content providers were exported by default. So if you didn't specify anything, the whole world could see them. And of course, that's where all your secrets are. So everybody would just steal the secrets right and left, and it was pretty ridiculous. Everybody seems to make this mistake. So Drozer provides this thing, run app provider info, to give you information about the content providers. And when you do it, you will see the content providers. So let me do this one live. Let's get it here. It's pretty much the same as you'd see there, but it's better to see everything live as much as possible so you see all the little things that go wrong. And CNIT is being very good at showing you all the irritating things that go wrong. And that's good because you will have to solve them yourself when you get to it. So I'm looking for my content providers, and it's too annoying to find on my list, so I'm just going to get it here. App provider info. Okay, so let's find one of the run commands like this one. There. It's like this one, but it's app provider info. Okay, so provider. Okay, and I don't know about that -u. I'm going to leave that off for the moment. All right, let's try the, see how this one looks. So I got to get out of here and back in Drozer. And it's still connected. Wonder of wonders. It didn't hang up on me. Something must be wrong. And so now I do app provider info, and I get the apps. Now here's an authority, file backup provider. That's what runs those backup options we saw in the settings app. And here's database control provider, content provider, which apparently lets me access the stored data, which probably includes your stored passwords. And notice, read and write permissions are null, which means you do not need to have any permissions to read or write to this, which does seem like a pretty bad idea, if you ask me. But down here, this part has permissions. Read permissions and write permissions. You actually have permission to read keys and write keys to the keys subfolder. So apparently the developer felt like this database, there's only one part of it that's secret, and that's the keys folder, and that they require permissions for. And that would be fine if that was really true. It's going to turn out, of course, that that is not true, but they protected the keys folder, and they didn't protect anything else. This also has permissions. No, these other things are available to anybody. So, let me go back to my slides and figure out how to make my thing move. All right, so now you need to find URI paths to attack content providers. just like web pages, you have to have a URL to get them. You have to have a content / path to get into it. Now, the URIs are developed by the designer, and they might not be documented anywhere. It might not be easy to figure them out. Now, there is a module just to find them called Find URLs. Let me see if I've got it here. I should. Find URLs. I don't. All right, I've got to put it in. Somehow it's not in my list of copy and paste things, which is not surprising because I was getting pretty frustrated preparing this lecture, struggling with these commands. And so it's find URLs, the same thing. That's pretty easy. So let's just change scanner provider find URLs. It looks pretty easy. Okay, what this will do, and it does not have the -u on the end. Okay, good. So this will attempt to find the addresses of things to attack in the database. And I probably spelled it wrong or something. Scanner provider. Where's the slides? Okay, scanner provider find URLs. What did I do? Oh, -a. Maybe I don't have the -a. I do have the -a. All right. This is what I spent a lot of the last several days doing. Hearing these things one by one to find out, because nothing worked until like the 4th or 5th try. It is very difficult to get these things right. All right, somehow there's a difference between that and this. Run scanner.provider.find URLs.
Is it URIs?
It's URLs. Unknown module. Wait, and now it's fine. It is find URIs. Thank you. Good. Okay, I'm duplicating my old mistakes. For some reason, I made a copy containing a mistake for my slides. That was not what I intended. Good. Find URI. Yes, thank you. Good. All right. Good. I didn't mean to put that on the slide, but that's fine. Like I said, the reason I'm doing it live is largely for this reason, because you're all going to have to suffer through all this when I finish writing this stuff up, or if you want to work through the project. So it's URIs, and there we go. This looks really good. If various things it couldn't find, and then it found 3 accessible content URIs. The problem is it doesn't do a very good search at all. All it's doing is looking at the binary dex file and running strings on it and looking for strings that start with content. So this is like web pages where you run a spider, and all it finds is the web pages where there is a link to that page. It can't find anything else. So it's very likely that there are things that are not explicitly referred to, and it won't find them. But for what it's worth, it found some things, and what it found that there's a keys folder and there's a passwords folder. And the interesting thing, of course, is that the passwords folder has no permissions on it, because the only permissions apply to the keys folder. So if there's anything important in the passwords folder, I can get to it, and it sounds like there might be something important in there from the name. So that's an interesting finding. All right. So now you have a query, and that's app provider query content with the thing content, genuine content provider passwords. And when you do that, you should get it. Let me just run that one. It should be available. And I'm determined to stick to doing this live because I'm having so much trouble, and that's good. So passwords. All right, there it is. Run app provider. That looks pretty right. Let's see if that works. And it does work. And so it's got my stored usernames for Twitter and Facebook, and it's got my passwords, but the passwords are base64 encoded and apparently encrypted in some way. And this one here, I actually added. Anyway, anyway, so this works. It gets me in that folder that was unprotected, and I did it from Drozer. So I did it from a different low privilege user account on the box. So it is actually really bad that I can get your passwords from here, although if you were to report this as a vulnerability, the defensive designer would say, well, there's another layer of encryption protecting it, so everything's fine. They always tell you that. Every time you find something, they always tell you, oh, that doesn't matter. That's always the answer. Like the Pope. Oh, just shut up, everything will be fine. Anyway, it's the natural response of every authority figure to just shoot the messenger and carry on. So, all right, so now you can insert content, which is why I had another record there. I don't know why you'd want to do this. It's just, I both read and write privileges. So you can insert content, and this is a really long one, but you can insert a new record with the name and password and add it in. But the problem is you don't know how to make an encrypted password in that goofy format. So you can copy this encryption code and have another password the same. You can do this in the Linux etch password file too, or etch shadow file. You can make an identical account with the same password, even though you don't know what it is, but I'm not quite sure what the point of that is. You could lock people out by changing this, then they couldn't get in with any password anymore. But anyway, that's so you can add another record, whatever good that is. Might be just a prank or something. Not very exciting. So you can do this from a shell, by the way. You do not need Drozer for any of this. Drozer is really just a convenience. You can open a shell, and then you can do everything with commands like AM to send intents, and content query is the local command that does it from the shell. And of course, if you do that, you are running as root unless you do a switch user to change yourself to another privilege. So everything you're doing in Drozer, you could just go to ADB shell and then do SU to another account and run it from there. Drozer is just a convenience. All right, so now you can find the unexported content providers. If you put a -U at the end, you will see them all, and then you'll see the unexported content providers, which you can only get at as root. And so as you expect, the same thing happens. Then you might find other things to exploit, but they'd only be exploitable by root users, so it's a lower risk. And then there's SQL injection, which is very similar to SQL injection on the web. So there are in principle several database stores supported in Android, but the one people use most often is SQLite. And it's just like Microsoft SQL or MySQL, it's just as vulnerable. So you have queries that look like this: select projection from table name URI, where selection equals selection args, order by sort order, just like any other SQL. The bold things are parameters. And if you have control over one of them, and you can put in special characters like semicolon and dash dash and apostrophe, you can inject stuff which will be misunderstood. So if you send content : setting system for the URI and projection star, then you get select star from system, which gives you everything. And that's here. If I query, now here, I send a projection of an apostrophe. So let me do this one live, because this is the important one. And I should have those ready to go, more or less. I can't. SQL tables password. Yeah, I can't find anything out of your search. Projection. There. Okay. So here's the one with the apostrophe. All right. I'm still connected. So I'm sending a query content. What is that? Jakar, I've seen Diva. This is something else. Okay. Something else I did. And if you hit Control-C in Drozer, by the way, it kicks you out of Drozer, just for good, clean fun. So I'll have to get back in Drozer, but first I need to find, that's a different vulnerable one. Right, so apparently I didn't save any of these. Great, okay. Fine. Let me see if I can create one, find out where I am. Here's where I was supposedly saving things, but somehow I failed to save them, which is pretty common. All right, so I want to run app provider. I got this far, okay. Let's see if I can make one here. Okay, and get this junk on the screen the same as that. Okay, so hopefully I have a good one here and not a broken one. App provider query, and then content. I probably have that up here. Content, okay, here's my content, and I want the one that goes to passwords with a slash, so that's this one. I definitely want to copy that instead of trying to type that in. Okay, so it's this junk, query, then the content goes here, then dash dash projection, single quote, and that's it, I think. Let's see if that actually works. All right. Oh, I got to get back in Drozer. Oh, good, it didn't hang up on me. Okay, I do that, and it works. Okay, this now in the typical case where you're doing SQL injection into a web app on the web, you see SQL syntax error. This is the analogous error from Android. Unrecognized token, apostrophe from passwords. It read it up to the apostrophe, and then it crashed because it couldn't understand it after that. While compiling, select apostrophe from passwords. At this point, it couldn't understand it anymore because the second apostrophe is missing. So this is the same meaning as a SQL syntax error you'd see from MySQL. It's just expressed differently. So this means I have SQL injection because I'm able to inject a character that breaks the syntax. So all I have to do is inject more careful things that don't break the syntax, but turn it into a valid command. And for that, I want this sort of thing, star from SQLite master, where type equals table. So let me get back to here, and let's copy this one. And the only part I have to change is the part inside there. So it is, I can only get this junk to stay on the same screen at the same time. All right, so it's apostrophe, not apostrophe, but star, from SQL master where type equals table, semicolon dash dash. All right, now we do this and then we'll talk about it because this is, it may look daunting at first, but you get used to this in the world of SQL injection. And I fouled it up, so we'll get there. But anyway, so I have the projection equal to this, and it got it. So unknown syntax, it couldn't even understand my command at all. So let me figure out what I've done wrong here. Okay, run. Oh, I'm missing the run. Looks like I'm totally missing the run. And I'm missing the app. I've only got the second line of it or something. Oh, yeah, that's right. It's 3 lines. Okay, that'll totally do it. Okay. All right. Let's see what that one does. Ah, that one actually works. Okay, good. So, so understand, I run. This is the query that's the database. This is the content URL that points to the passwords area. Here's the projection, which is a parameter I control. In there, I put in star from SQLite master. Now this SQLite master is super important, and the same thing happens when you do MySQL or MS SQL. You're querying an automatically created database, which always has the same name. That is why this works. If they didn't automatically create certain tables with always the same name, SQL injection would be almost impossible. You'd have to guess at the names. You don't really have to guess at anything because the database maintains its own internal structure using standard tables that it creates. And you can query those tables and they'll tell you where all the other tables are. So nothing can really be hidden. This is like the people that try to hide their passwords, keys on the phone, and then they give me an Android app and I can see your source code. You can't hide anything from me when I can see your source code. And you can't hide any tables from me when I can see the master tables that list where all the tables are. But I do have to know how to query them. So I have to query this name and then where type equals table. So that will create the complete query I want. Now I could now have another apostrophe or A equals A or something, but the alternative is to have a comment code here. So what that will do is cause the rest of the line to be ignored. And that makes this a valid command. And now it tells me that I have tables, a table named Android metadata, passwords, and key. And the metadata is another one of those automatically generated tables I could go into for more information about the database if I needed it. But it turns out I don't need any more information about the database than what I have. And now I can dump the keys. I just need to do this. To dump the table, that looks like identical to the last one. It is identical to the last one. That's the wrong picture. So I'm going to have to skip it for the moment. Let me go to my project. It's in the project, so I will get it there because this is in one of your projects. So let me get it there. All right, this is 128 projects. This is the Drozer project here. And you do this at the end of it, you get these things. So there is the one this is the one that enumerates table names. And it's just this last one here. So I'm going to fix it. It is this command here. Let's see if it runs. And then I can talk about it. It does run. So one of my slides is wrong. I'll patch it up. But the point is, this is the one that does a different, and it's just star from key. I know there's a key table, so I go for the key and I get the passwords. Now, there was another table called passwords. I should be able to dump that one too. Let's try passwords. And it does work. It gives me those hashed passwords. Now, I haven't yet learned how to decrypt them, but I have been able to dump the data. And notice that the master password for the whole thing is stored in plain text, and so is the PIN. So I don't really need to decrypt these. This is very common. They lock one door and leave the back door swinging open so it doesn't accomplish a bloody thing. Since I have that, I can just go in the app and log in and get in. But you can also reverse engineer the encryption and find out how this works. And that's, I think, in other tutorials about this. Anyway.
How is the master key master key getting to the user line to the trigger?
How does the master key what?
The master key.
How do I get in here? You open the app and then log in with that. And now you're the real user. And now you can see your Twitter password. So this is, by the way, true of malware too. If you have something encrypted, the easiest way to decrypt it is to run the malware and use the code that they wrote to decrypt it.
But your master key only get you into the phone, right?
No, this master key gets me into this password manager. And then I can totally see this. So this is what you typically do if you have an encrypted thing, is use the code that the other guy wrote to decrypt it.
Can you demo it in here?
No, I can show you how to do it though. Doing it here is difficult. You can do it here. You just go here and you launch Civ, and now it asks you for a password, and now I know that password. So I can put it in here.
I think I think the password doesn't, the browser password doesn't even app, it's the password.
What was that? Yeah, see now, I just log in here. And now that I'm in, I can now totally go in here and see the passwords. If this thing is going to work, which it doesn't seem to. French?
Password for the password manager, password for the app.
Yeah, that's the idea. Once I'm in the password manager, there should be a way to see it, although I'm not having password copied to clipboard. There. That copying it to clipboard, let's see if I can paste it in something like this here. Yep, there it is. The password has let me in. So once you're in the app, you can get the passwords. Good. All right, let me see where we are. We are here at only 23, so we're also coming to the hour. So I think we ought to take a 10-minute break till 10 after and then carry on because there's more to come. And then some Kahoots coming. So I'll pause here for 10 minutes. I'm going to leave the share going, but stop the recording. Zoom recording. And let me see this chat here, and then I'll get to that one. Okay, the wall has a secret route for film directors. A car was hacked.
No, because
Rolling Stone. Okay, I don't know any of this. Now what were you saying?
The browser have access to the phone, have access to everything in the phone.
Drozer does not by default. It only has access.
The password and the keys.
Well, Drozer is running without root privileges, so it can only get published intents. So it can only access the password and keys if they're really wide open. If you log in with Chell or escalate to root, there might be a way to escalate to root inside Drozer, I'm not sure, then you can do more. That's a good, anyway, so here you can, in principle, this exports this provider's with a web interface, and now you can use other hacking tools like SQL Map. In practice, I can't make it work very well at all. And this being, I wonder about Drozer. Drozer is generally regarded as very good when I Google and see what people say as the leading tool, but it looks to me like it's kind of been abandoned for about 2 years, and I wonder if there's another better tool out there, like maybe a commercial tool you have to pay for that's better. I did see a few that are like vulnerability scanners like Nessus for Android that will like give you a GUI and everything, and they were like monstrously difficult to set up. So but I kind of, I'm just learning Drozer, and yet I'm seeing the clues that Drozer has already been abandoned and there's something coming up after it. So maybe there'll be another book coming out with whatever's after this. Drozer is pretty buggy. It looks to me, this is true of most hacking tools, most free hacking tools. They don't, like Kali, they only get to a point where it sort of works, and then eventually all the developers leave and go out to something that makes a pile of money. There may be some friendlier, nicer thing to use. Anyway, we can talk about some Samsung vulnerabilities. In 2011, they found the content providers were wide open on Samsung, and you could totally get in everything like this password thing. And this was in the OS of Samsung devices, not in the apps. So you could read the instant messages and the calls and the GPS and everything from all the apps. That because they didn't have read permissions. They also had a SQL injection that exposed all your SMSs, and that's getting to be a while ago. Now there's also file-backed content providers, which instead of being a SQLite database, point to a file. And so they have a public content provider with this. The person who wrote the app in Java would do this, make a public partial file descriptor that opens a file. And so if you do this, you get the URI from an intent from another app, and you shouldn't trust it because it might have punctuation characters in it. So you should be validating it before using it, but of course the developers might forget to do that, and then you can replace the URI with something that points out of your folder to some other folder. And this is one you typically use. System at host is just a folder that is available to everyone. This is why people use ets password on Linux. That's a folder that has read permissions to everyone. So when you want to see if you have what they call directory traversal or local file inclusion, are the names for this on the web, you go for a folder that is definitely readable and see if you can get there. So here's one. So you can do that. You can read with the app provider read content. You can go here and you can give it for your file backup. You then put in system etc hosts, and it will then show you the contents of local hosts, which is, of course, just the resolving of IP addresses to names. And just like on Microsoft and all other operating systems these days, the only thing in the host file is the loopback address these days. Back in the 70s, it used to contain the locations of real websites, but now it's pretty much just a useless stub. Anyway, so you can do this in SID. It took me a while to get the command working, but I finally got it working. You can do this databases. You can refer to it directly, go through the file backup provider, and you can then give it a path. You should recognize this from before. This is the home of SIV, data, com, mjar example.siv, then databases, then databases. Now the book says you'll find one file called database.db, but that's not what I found. I found 3 files with funny extensions, and the one called -WAL is the one that really had the passwords. So something has changed, even though I'm using the same app, which I assume is because a different Android version has some kind of different implementation of SQLite. But I did get it, and it dumps out the readable part of it, and you can see things like the master password here in plain text, and the other stuff is like encrypted and hard to read. But anyway, you can see the main point there. You can steal the password off the phone by querying the content provider correctly. This is directly. All right, and you can detect directory traversal vulnerability with this thing, provider traversal. This will tell you if it's able to do directory traversal by seeing if it can inject like ... which is the common directory traversal. All right, so here, if you go to look at your provider info, then you'll see the path is keys here. And that keys is limited, read keys and write keys. We've done this before. But it turns out that that is implemented by this man. You can look at the manifest in Drozer, which is kind of nice. This command, app package manifest, will just let you see the manifest file. The way we've done this in the earlier project is by downloading the APK, unpacking it with APK tool, and looking directly at the manifest.xml. And you can do that, but you can do it in Drozer, which is more convenient. It dumps out the manifest in its complete readable form. So the manifest is XML. It starts with this stuff. And down in the middle, you have the provider, DB content provider. This is the provider we're exploiting. And here are the permissions, read permission and write permission. And here is what is protected, path equals /keys. Now that looks good, but it is not good. Any more than it would be good in a Apache configuration file where a similar error happens a lot. This only protects exact matches to that path. So it only protects /keys. It does not protect /keys/, because that is not an exact match. So if you go to the query content and you try to dump provider/keys, you get a permission denial. But if you try to dump provider/keys/, you get the password. This is the problem. They needed to put in another path match there or a wildcard or something. And if they forget to, this happens. And this happens a lot in Apache configuration files. All right, anyway, then there are services. So this was that. First he started with activities, which are the things that pop up visible screens. Then we went to the content providers, which is the databases. There's 2 more things that can happen on the phone, and it's all very similar. There are services. The services are just like in Windows. They are things that keep running all the time in the background. So things that must run continuously, like, for example, you might have a service to check for updates or service to, so these are things that might be running in the background. You can launch them with an intent. You can stop them with an intent. You can just have your app launch them like at install time and leave them going forever, or you can bind an app to a service and it will send and receive messages from the service. There's an onStart command which will receive intents to start the service, and when it does, it runs a activity as soon as it starts. So that is a place you could put malicious activity or mistaken activity, and you can interact with these things with run app service start. So Samsung had a vulnerability here because there was a clipboard running. Now the clipboard is obviously a service that should be running all the time in case you want to copy something to the clipboard and then paste it somewhere else. There has to be a service running to do that, and there is in Windows and there is in the Mac. But the problem is the clipboard did not consider some possibilities. And so you could take something, copy it onto the SD card, and then call the clipboard again and copy it back into the data folder, and you just installed an app. And the Clipboard service ran with high privileges, and you didn't have to have any privileges to use it. So you could escalate your privileges to root. You could have a low privilege app that installed another app, even though you don't have install apps permission. This is the kind of thing that keeps happening. This is how privilege escalation works. You just go by a sort of indirect path, and you end up doing the bad thing. So that was pretty good. All right, so that was what happened there. Now there are unprotected bound services. These things are remote procedure calls, the most vulnerable part of Windows. The RPCs are responsible for most of the viruses. So you bind to something, then it returns an iBinder. That's how it's implemented. And you can, there's 3 ways to have a bound service. You extend the binder class in Java, and this lets you have other parts of your app talk to it, but it does not go across the sandbox, which means you cannot let any other app in. So this is relatively harmless. You can use messengers, and this is what most everybody does. They send messages to each other, little internal messages through the intent system, and the apps receive them. That's how apps talk to each other. There's this thing, which is possibly more secure, but it's more baffling and nobody uses it, called Android Interface Decryption Language. This is the inter-process communication method, and it has these AIDL files. And in principle, you can use this, and in principle, it can be vulnerable. But in practice, most people just ignore it and use the messages system that's easier. All right, so if you want to attack the messenger system, which is probably the reasonable one, then there's a handle message method. And so they started showing source code in your textbook just blithely, and I looked and there is no source code available, so I had to get it, but you can find it. So if you look for the services in SID, you can do app service info on the SID and it will show you the services. There's an auth service and a crypto service. And by the way, I found I think part of your textbook explains how to use the crypto service to decrypt those encrypted passwords. I decided not to include it in tonight's lecture because it was already enough material, but you can exploit that one. But then I wanted to see the source code for this app, and I realized I totally know how to do it. It's in the later projects. I learned it from the Indian guy, the guy in France that hacked the Indian government app, which you'll see around project 12 or 13, showed me how to do this. I did it on Windows, although you can do it on Kali too. This thing here, JADX, this thing takes apps and shows you Java source code, and it's very good. And so this is the Civ app, civ.apk. You just open it in this thing, and it shows you all the Java code in a nice tree-structured directory, and here's the message handler. So this thing uses these message inter-app communications, and there it is, and you can just see it here, and it's very readable. And with the guidance of your textbook, I can see pretty quickly how this works. There are code numbers coming in for messages. So there's a code to check data and a code to write data called check and set. So a 2354 reads data. And there's a code to read the key and a code to read the PIN, which is 7452 and 9234. There are just these 4-digit numbers for code numbers. So all you have to do is send a request with the right code numbers, and it just coughs up the password. It's pretty awesome. So that's coming up here. Took me a while to figure out, but the end result is pretty simple. And there it is. You send app service send this mess auth service with a message with 2254, 9344, and then a few other things. Now this is the one, and the reason this exists is because you could have another app. Remember, if you have like Twitter, and you go to a website, it says, "Oh, log in with Twitter." You can, so that my website can ask Twitter who you are, and Twitter will tell me who you are. And apps on your phone can do that. I want to log in with this other app. So it has the ability to request the password from the password manager to fill in for you here. In order to do that, it has to provide the PIN to get the password. So you have to know the PIN. It's in there, PIN 1234. And if you give it the correct PIN, it will cough up the password in plain text. Now that might look secure, but of course it's not, because you can brute force that PIN. It's in code. You can just write a script that will just try all the pins until you get in. And the other one will take the password and turn it back into the PIN. And so the exporting these subjects you to a trivial local brute force attack. And that's the game. And then there's broadcast receivers, which are the things that listen for signals that are sent out. And so you could have an app that worked like this. Suppose you wrote an app like this. You have some kind of login. You take name and password from the user. Then you send it to some website, decide that they're okay. Now you send a broadcast saying, correct credits. This is how the San Francisco parking meters worked. So then the app designer writes this thing to have a login receiver, which is exported. So things can come in signals from the outside, and they wait for this signal that says correct creds. The problem is, of course, I can just make an app that sends the correct creds message without bothering to check the creds first. And that's what happened with the San Francisco parking meters. When you try to pay for parking with your card, the phone asks the card, do you have enough money? And the card answers yes or no. So you can make a modified card that always says yes and just have all the parking you want. They trust some secondary signal, which is not reliable, instead of going to a central repository that's secure to make sure you're getting the truth. Yeah.
Does it work or not?
I don't know. That was maybe 7 or 8 years. I imagine they patched it, but who knows? It probably would cost a lot of money to patch. I imagine they're probably just going to leave the old meters in use until they wear out. That's what I would probably do.
They upgraded the meters to the way you can now use credit cards, so they must have done some upgrade.
Yeah, so it might be fixed by now. I know, by the way, there's another attack I just learned about. See, DEF CON just tweeted that they're going down for 2 days because someone stole their power meter. And I've learned, yes, they pried the power meter off the wall, that old spinning dial, and I've learned this is now a common theft. What you do is you steal somebody else's power meter, then you put it on the ground and wait until the meter reader comes, pop it in, and then they get a low number. Then you put it back. There's people are doing this to save on their power. So it's fairly common that somebody comes in at night with a crowbar and they steal your meter, and then your power's gone, and he said it's going to take like 2 or 3 days for the power company to give them another one. So DEF CON's gone for a while. It's just a new fun attack. Anyway, that's a low-tech hack. Well, I remember when people used to.
How do they get somebody's meter that they put it into their own house or something?
Yeah, yeah. They put it in their own house, then the meter reader comes, then you pull it and put in the other one, and then when he comes, you put it back in, and it's only moved a little bit, so they charge you for less power. That's the idea.
The switcheroo.
Yeah.
It's like just taking a license plate.
Yeah.
So you borrow
Yeah.
someone else's license plate.
Like borrow someone's license plate.
So they charge them instead of you.
Exactly. Yeah.
Your meters and then you.
Well, those are the old hacks. There used to be a hack where you put a magnet outside the meter to change the way it spins. Those they apparently patched. So, like DEF CON's out of power. You can't get power without the meter running. But apparently you can swap in the meters. So I guess they're going to need to put like a token on the meter to identify an illegitimate meter or a password or something. But just, this is the way it always is. They only add security when they have to. And I guess this attack is getting common enough that they're going to have to upgrade the meters to some better protocol. So anyway, this one in 2013 came out. There were broadcast receivers in the Android code base that would let you initiate and terminate phone calls from anywhere. There was another one I heard about, the Skype app would let any app make Skype calls. So you could make a web page that would just make Skype calls. And this one turns into something pretty fun in a minute. Anyways, this was, anybody could make phone calls, which is really bad because they could call like a toll number and you get billed for it and everything. So I remember the patch for this came out was now Android will never make a phone call without popping out a box first saying, this app is trying to make a phone call, is that okay? This is the same as Microsoft's user account control. Let's ask the user every time. That's one layer of defense. Anyway, then there's intent sniffing. If you send an intent and it's a broadcast intent, that means any app can read it. And so you might put secrets in the intent. That would be a bad idea. But of course, there's no operating system technology preventing it. You're just supposed to know better. And of course, a lot of developers don't really understand what they're doing. So they might do something like this, send your name and password in the intent. And if they do, they should not let the intent be listened to by everyone. So you can snip it like this with app broadcast snip. This is like sniffing passwords off the wire. You can run a broadcast sniffer in Drozer, and it will listen for all the broadcasts, and you'll see them go by. And if somebody's putting secrets in the broadcast, it's just like they're putting secrets in the log. You can see it go by. This is actually, I should probably test this for the apps. I find like about 1 app in 50 puts secrets in the log. This might be more common. This is one of those easy tests I could be running on all the bank apps and everything. I should check it out. Anyway, this one is really fun. Let me do this one live. I heard about this, but I didn't know how Drozer makes this even more fun. Secret codes. Okay, run scanner misc secret codes. Now that's a pretty friendly, simple command. What this does is it finds the secret key presses you can type in. There's like *69, you all know to get the number that calls you. There's a bunch of others. This hunts through all the packages and finds all their secret key codes. Apparently there's a pattern to it. I think it's just doing strings and finding the control characters around it. So this Android GMS, whatever that is, has a bunch of them. Android settings, Android email has one. Provider's calendar has one. So those are the secret codes that'll do something on the dial pad. So here's one called settings that is 4636, and you can totally do it. So that means you have to put in like *#, 4646. There's a pattern, and I've got it here on my next slide. Okay. There. It's *#, 4636. You can totally do it, although it took me a while to figure out how to get to the dialer. You go to the phone, you go to the dialer, okay. And now it's, okay, *#, pound, *#, 4636. And then, no, that's right, *#, then star, but it's then pound star. If I get it right, there, it pops up the testing box. This is the secret code for that. This is a relatively harmless one that's there. There's a bunch of other ones, people knew them, and this has turned out to lead to a lot of problems. People think these are secret, and they're not all that secret, as you can see. So I can do this one, that's fine, but Samsung Galaxies had a factory reset this way. So if people would type this, they'd lose everything. Now that would be okay, but the other problem is you don't have to type it. You can put it on a web page because you can just put tel:, and the telephone handler will take the URL and put it on the telephone. And you could put it in ahref, click here to do it, but you can also put it in something that runs automatically like JavaScript or an iframe or on body or something. And if you do that, then it'll automatically dial that stuff in the phone, or at least it would in earlier versions of Android. So I made a demo of this where it'll try to do that settings thing, and I found out it appears to me that it has been patched in modern versions of Android. But it's here, ad.samsclass.info, 128 settings.htm. Let me open it up here so you can see it. ad.samsclass.info, 128 settings.htm. I put a few versions of it here. Okay, let's view the source code here. Oh, look, it's trying to load something from my browser. That's what it's trying to launch FaceTime with that tel. So the tel, now Firefox at least popped up a box to warn me. Tel apparently would open FaceTime. So you could make an app that makes a FaceTime call to someone, but Firefox will at least pop up a box to warn you. But anyway, if you view this page, here's what it has. Oops, here's my source code, there we go. Okay, I put it in an iframe, which is what they did in your textbook, which should have run automatically. And then I put it in an ahref, click here, because I found it didn't run automatically on my phone, but I'm Android 9. I think if you go back to like Android 4, it'll just dial automatically, but I think they got fed up with this and it no longer dials automatically. So if I open that, ad.samsclass.info on the phone, in the browser, so here's the browser, and it's ad.samsclass, whoa, stop that, ad.samsclass.info. They lost the D. Yeah, my,
Typo.
it's not listening to me too well. The phone is a little flaky. Anyway, /128/settings.htm. Okay, that should do it. And yeah, so it opens the iframe and does not go to the settings page. So that does not work on my phone, but the click here does work. So I think they have implemented some defenses. But if you had a third-party browser, like there are these horrible secure browsers that I found are not secure at all, I wonder if they would fall for this and things like that. I don't know exactly at what layer it's been patched. I don't know if it's patched in the browser or the OS. I know the Skype vulnerability was patched in the OS, where they said anything that calls up the dialer has to ask you first. But anyway, that's good, clean fun. All right, wasn't that an Applebaum? Yeah, Applebaum was, I think, involved in the parking meter hack. Yeah, that was back when he was still at Noisebridge. He was involved in most things Noisebridge did at that time. It was Joe Grand, I knew, was a big feature in the parking meter hack. And
Who was Applebaum?
Applebaum was one of the founders of the Noisebridge hackerspace in San Francisco, and they did quite a lot of interesting security research, but they also did a lot of disturbing illegal things, and he eventually sort of got ran out of the country and fired from everything for like abusing people sexually, sort of like the Me Too movement. He was like sort of like Julian Assange, his hero. He was playing fast and loose with all the groupies that worshiped him for being a hero by being a rebel. And so it's sort of in Germany especially, they have a sort of weird Ayn Rand type sex cult of people that are saving the world, and they all take drugs and sleep with each other and then get mad about it. And, you know, well, it's like, you know, like Timothy Leary. You know, people that are saving the world tend to be that way. They form a little tribe, and then after a while, everyone gets sort of disillusioned and they hate each other. So, you know. Anyway, so I got a few Kahoots, and that'll do for today.
And there's also a command to ID your phone number.
Yes, a star something or other to see your phone. Yeah.
So I think that the Sonic Check support does it. They use that to check if your line is working.
Yeah, there's a bunch of them. And there's a bunch on smartphones that are different again and have special features. So this is 128.7b. That's right. This is the one. Okay. So they want me to teach these classes in Saudi Arabia, but they told me I can't have the Kahoot music. I didn't know this, but apparently observant Muslims cannot listen to music. If you can't have any music in your class, that would offend your students. I was like,
Just mute it, right?
I know. Now, what's funny is this was also true of the Protestants where I grew up, like the Puritans and stuff. No music, music and dancing were considered evil. You know, I think a very similar issue, you know, with why are you doing this? This is frivolous. This is like distracting you from God. We had the same attitude. Remember when I was a young, raging fundamentalist Christian, there was some observant Muslims that came to my college, and most of them went off and broke the rules, and one of them was strict, and he and I got along just fine. The strict Muslim totally agreed with me. At one point, we tried to talk about our gods, and that was going to lead to trouble, so we avoided that topic after that. But on everything else, we totally agree. We should be in here doing our homework and not out there with those sinners having fun. That would be awful. We were totally on page about that.
It'd be more funny if two users have the same name and one picks the other.
That could certainly happen. Yeah, music is sin. That's it. Music and dancing is sin, and cards are sin, and booze is sin, and anything fun is sin. God wants you to suffer. That's the Puritan way. Anyway. My dad used to say, if you have a burn, you should put hot water on it because it hurts so much, it must be good for you. It's the same kind of philosophy. That was the philosophy that it came from this. It was a form of. If you were a Puritan, this would make sense to you. My mom said, this is what Ambrose Bierce said. He said, a Puritan is someone that can't stand the thought that somewhere someone else might be having a good time. And that is pretty much how it is. Anyway. All right. Anyway, 14, I guess I'll give it a few more seconds, but we might have them all. Oh, we don't. Okay, wait, no, we're losing them. Okay, well, then we better go ahead since people are in fact dying while waiting in line. I guess we should get going here. All right, so maybe they're using Android phones and it's dropping their connection. So, all right, so which item makes a screen pop up and can be launched from browser? Make it bigger. Higher. It's got to be an exported activity. Activities are the things you can see on the screen. Providers you cannot see, they're in the background. And it has to be exported if you're going to launch it from Drozer, because Drozer doesn't have root privileges the way we're using it anyway. All right, which one of these might have SQL injection vulnerabilities? Okay, content providers are where they are, and the exported ones are, of course, the easy ones to exploit. All right, which one allowed privilege escalation by the clipboard in Samsung? Okay, that was the exported service. All right, and which one has to be protected to prevent intent sniffing? your broadcast receiver needs to have permissions, so not everybody can see it, or everybody can see your intents, and that might not be good depending on what kind of information you put in the intents. So music is sin. They'll have to identify themselves. Forest and M. Okay, and this might be the identification coming in on the chat message here. It is. Okay, good. Okay. All right. And good. All right. So, and this is CNIT 128 cahoots. And it is 2:27. Okay, well, I guess that's it. I'm going to shut this down and go upstairs and see if I can help anybody. Many people are suffering greatly on the project, especially the ones that use Windows. It's not easy on any OS. It is possible on Windows, but even more difficult. If you get fed up with it, go to a Mac, and it will be less painful. Although it never gets. Yeah, well, it turns out it has to do with the networking is the big problem. And the simulated networking is always a big problem.
VirtualBox has a new version of VirtualBox, so it's working much better.
Oh, you have a faith that I don't have. Usually they break everything. Anyway, all right, so I'm stopping the share, and I'll go upstairs. No, in fact, I was just at a conference, and they told